pa rin, Tatak City High.
A pleasant day, mathletes! I'll be your math teacher for today. I will walk you through the simplest possible way of understanding today's lesson. Feel free to pause the video to jot down important concepts. Mathematics is numbers. Numbers are integers. Real-life situations can be calculated in integer value as well. Integer value is either positive or negative for real-life situations. Real-life integers play an important role in calculating our daily activities. Therefore, integers are not just a topic to study. It works in real-life situations as well. We are not done yet in dealing with integers because today's lesson is all about properties of the operations on integers. So, at the end of this lesson, you are expected to be able to state and illustrate the different properties of the operations on integers. In math, the whole numbers and negative numbers together are called integers. The set of all integers is denoted by z, as shown in this figure. Properties of integers determine its operations. These properties helps us to solve many equations. The following are the important properties of integers: closure property, associative property, commutative property, identity property, inverse property, and distributive property. Let's talk about closure property first. Closure property, under addition, subtraction, and multiplication, states that the sum, difference, and product of any two integers is also an integer. In symbol, if a and b are integers, then a plus b, a minus b, and a times b is an integer. Say for example 4 plus 8 is equal to 12. The addends 4 and 8 are integers. Therefore, the sum, which is 12, is also an integer. Same goes with 5 plus negative 7 is equal to negative 2. The addends 5 and negative 7 are integers. Therefore, the sum, which is negative 2, is also an integer. Meaning to say, the set of integers is closed under addition. Another example under closure property is 15 minus 9 is equal to 6. Since the minuend 15 and subtrahend 9 are integers, therefore, the difference 6 is also an integer. Another is 13 minus 21 is equal to negative 8. Where the minuend 13 and the subtrahend 21 are integers. Therefore, the difference negative 8 is also an integer. From the examples, it is clear that subtraction of any two integers again results to an integer. In general, for any two integers a and b, a minus b is an integer. Therefore, the set of integers is closed under subtraction. Of course, another example, 12 times 4 is equal to 48, where the multiplier 12 and the multiplicand 4 are integers. Therefore, the product 48 is also an integer. And another, negative 3 times 11 is equal to negative 33, where the multiplier negative 3 and the multiplicand 11 are integers. Therefore, the product negative 33 is also an integer. In general, we can say that integers are closed under multiplication. Let us take note that division of integers does not follow the closure property. In symbol, if a and b are integers, then a divided by b may or may not be an integer. Example, 15 divided by 3 is equal to 5, which is an integer. But 4 divided by 12 is equal to 1/3, which is not an integer. Another is commutative property. Commutative property of addition or multiplication states that changing the order of the addends or factors does not affect the sum or product. In symbols, if a and b are integers, then a plus b is equal to b plus a, or a times b is equal to b times a. Here is an example of commutative property. For addition, 14 plus 7 is equal to 7 plus 14. Which is true because 14 plus 7 is equal to 21, and 7 plus 14 is also equal to 21. Another example is negative 20 plus 5 is equal to 5 plus negative 20. Which is also true because negative 20 plus 5 is equal to negative 15, and 5 plus negative 20 is also equal to negative 15. While under multiplication, 12 times 4 is equal to 4 times 12, which is true because 12 times 4 is equal to 48, and 4 times 12 is also equal to 48. Another example is negative 5 times 3 is equal to 3 times negative 5, which is also true because negative 5 times 3 is equal to negative 15, and 3 times negative 5 is also equal to negative 15. Take note, subtraction is not commutative for integers. In symbol, if a and b are integers, then a minus b is not equal to b minus c. Let's say for example 17 minus 5. It is not equal to 5 minus 17 because 17 minus 5 is equal to 12, and 5 minus 17 is equal to negative 12. And also division is not commutative for integers. In symbol, if a and b are integers, then a divided by b is not equal to b divided by a. Let's say for example, 20 divided by 4. It is not equal to 4 divided by 20 because 20 divided by 4 is equal to 5, whereas 4 divided by 20 is equal to 1/5, and that 5 is not equal to 1/5. And now let's go to associative property. Associative property of addition or multiplication states that changing the grouping of the addends or factors does not affect the sum or product. In symbol, if a, b, and c are integers, then the quantity of a plus b plus c is equal to a plus the quantity of b plus c, or the quantity of a times b times c is equal to a times the quantity of b times c. Here's an example of associative property. The quantity of 2 plus 5 plus 8 is equal to 2 plus the quantity of 5 plus 8. Let's calculate first the operations inside the parentheses. And now we come up with 7 plus 8 is equal to 2 plus 13, which is true because 7 plus 8 is equal to 15, and 2 plus 13 is also equal to 15. Another example is the quantity of negative 6 plus 3 plus 7 is equal to negative 6 plus the quantity of 3 plus 7. Again, let's calculate first those that are inside the parentheses. So therefore, we come up with negative 3 plus 7 is equal to negative 6 plus 10, which is true because negative 3 plus 7 is equal to 4, and negative 6 plus 10 is also equal to 4. So both sides of the equation are equal. And for multiplication, the quantity of 4 times 3 times 2 is equal to 4 times the quantity of 3 times 2. Again, we calculate those that is inside the parentheses. So we come up with 12 times 2 is equal to 4 times 6, which is true because 12 times 2 is equal to 24, and 4 times 6 is equal to 24 as well. And take note, subtraction is not associative in nature. In symbol, if a, b, and c are integers, then the quantity of a minus b minus c is not equal to a minus the quantity of b minus c. Let's say for example, the quantity of 8 minus 3 minus 2 is not equal to 8 minus the quantity of 3 minus 2. Because if we calculate those that is inside the parentheses first, we come up with 5 minus 2, which is not equal to 8 minus 1. Because 5 minus 2 is equal to 3, and it is not equal to 8 minus 1, which is equal to 7. Therefore, we can say that subtraction is not associative in nature. Another is identity property. Identity property of addition states that any integer added to the identity element 0 will remain unchanged. 0 is the identity element of addition. In symbol, if a is an integer, then a plus 0 is equal to a, or 0 plus a is equal to a. These are examples of identity property of addition. 23 plus 0 is equal to 23. 0 plus 23 is equal to 23. Negative 7 plus 0 is equal to negative 7. And 0 plus negative 7 is equal to negative 7. While identity property of multiplication states that any number multiplied to the identity element 1 will remain unchanged. 1 is the identity element for multiplication. In symbol, if a is an integer, then a times 1 is equal to a. Here are a few examples of identity property of multiplication. 23 times 1 is equal to 23. 1 times 23 is equal to 23. Negative 7 times 1 is equal to negative 7. 1 times negative 7 is equal to negative 7. And now we go to inverse property. Inverse property of addition states that the sum of an integer and its additive inverse or opposite is the identity element 0. A and negative a are additive inverses. In symbol, if a is an integer, then a plus negative a is equal to 0, or negative a plus a is equal to 0. Here is an example. 9 plus negative 9 is equal to 0. Negative 9 plus 9 is equal to 0. Negative 4 plus 4 is equal to 0. 4 plus negative 4 is equal to 0. While the inverse property of multiplication states that the product of an integer and its multiplicative inverse or reciprocal is the identity. In symbol, if a is an integer, then a times 1 over a is equal to 1. And 1 over a times a is equal to 1, provided that a is not equal to 0. Here are a few examples. 5 times 1 over 5 is equal to 5 over 5 or equal to 1. Also, negative 4 times 1 over negative 4 is equal to negative 4 over negative 4, which is equal to 1. And of course, let's go to distributive property. Distributive property of multiplication over addition or subtraction states that multiplication distributes over addition or subtraction. In symbols, if a, b, and c are integer, then a times the quantity of b plus c is equal to a times b plus a times c, or a times the quantity of b minus c is equal to a times b minus a times c. Let's say, for example, 3 multiplied to the quantity of 4 plus 5. So, for distributive property, from the name itself, we have to distribute 3. And so, we come up with 3 times 4 plus 3 times 5. And this is actually true because both sides of the equation are equal. Because on the left side of the equation, if we're going to calculate first those that is inside the parentheses, we come up with 3 times 9. And on the other side of the equation, we come up with 12 plus 15, which are equal because 3 times 9 is equal to 27 and 12 plus 15 is equal to 27 as well. Another example is 5 times the quantity of 8 minus 3. So if we're going to use distributive property in this, we have to distribute 5. Therefore, we come up with 5 times 8 minus 5 times 3. And this equation actually is true because both sides of the equation are equal. On the left side of the equation, if we're going to calculate the inside of the parenthesis first, we come up with 5 times 5. And on the other side of the equation, we come up with 40 minus 15. And again, this is true because both sides of the equation are equal. Because when we multiply 5 and 5, we come up with 25, which is equal to the difference of 40 minus 15, which is 25. Therefore, both sides of the equation are equal. Well, that is all for today. I hope you've learned a lot. Thank you for watching. Have a great day.